How does a civilization that once moved millions of stones by hand now construct entire cities in the time it takes most countries to approve a building permit? The Great Wall of China took over 2,000 years to complete. Today, China builds functioning neighborhoods with schools, hospitals, and transit systems in under 2 years. This isn't just about construction speed. It's about how a nation's approach to solving problems transformed while its core philosophy remained the same. Stand at the Great Wall today and look out across the mountains. You're witnessing more than ancient engineering. You're seeing evidence of a civilization that understood something fundamental. Survival depends on thinking at scale. Every brick represents a vision that stretched across generations. The emperors who ordered its construction knew they wouldn't live to see it finished. They built it anyway. Now shift your perspective to Xiong'an, a fishing village 40 years ago, now a megacity of 12 million people. Skyscrapers rise from empty lots in 18 months. Smart sensors track traffic flow, energy consumption, air quality. The city learns, adapts, responds. 2 different eras, 2 different technologies. But is the thinking really that different? Both required coordinating massive human effort. Both demanded solutions to problems no one had solved before. Both viewed architecture not as art, but as survival strategy. The Great Wall protected against invasion. Smart cities protect against chaos and collapse under population density. China's architectural evolution isn't actually about architecture. It's about problem solving under impossible constraints. 2,000 years ago, the constraint was defending borders with pre-industrial technology. Today, it's housing urban populations larger than most countries with limited land. Throughout this journey, we'll explore the pause when innovation stopped, examine how buildings shape behavior, and ask uncomfortable questions about what comes next. Because if there's one pattern throughout Chinese architectural history, nothing stays the same for long. So let's start where it all began. How do you organize millions of people to achieve what seems impossible? Ancient China didn't build big because it wanted to impress anyone. It built big because anything smaller meant extinction. This is the part that gets lost when we admire the Great Wall as a tourist attraction. It wasn't a monument to ego. It was a solution to an existential threat. Understanding this mindset, this equation of architecture equals survival, is essential to understanding everything that comes after. Consider the geography. China sits surrounded by deserts, mountains, and hostile neighbors. For thousands of years, nomadic tribes from the north launched raids, stealing resources, disrupting harvests, threatening stability. A small wall wouldn't stop them. Only something massive, stretching across the entire northern border, had any chance of working. But here's what makes it remarkable. The engineering challenge wasn't the hardest part. The hardest part was organizing millions of workers over centuries without email, phones, or computers. Workers needed food, water, shelter, tools, materials. This required a philosophy of collective effort over individual ambition. The worker placing a brick would never see the finished wall. The emperor ordering construction would die long before completion. Everyone understood they were contributing to something bigger than their own lifetime. This same philosophy shows up everywhere in ancient Chinese architecture. The Forbidden City wasn't just a palace. It was a statement about order and hierarchy. Every building's position, every color choice, every dimension followed feng shui principles and Confucian philosophy. Nothing was random. Ancient Chinese builders became masters of working with what they had. They invented mortise and tenon joints so precise that buildings could flex during earthquakes without collapsing. No nails, no metal fasteners, just wood fitting into wood with mathematical precision. This is innovation born from constraint. The Great Wall was never just a wall. It was proof that China could think at scale, organize at scale, execute at scale. That capability didn't disappear. It just waited for new problems to solve. Here's what nobody talks about. For centuries, Chinese architecture barely changed at all. After pioneering construction techniques that the rest of the world couldn't match, Chinese architecture just stopped evolving. This isn't a criticism, it's a pattern. And understanding why innovation paused is the key to understanding why it eventually exploded. During the Ming and Qing dynasties, architectural styles became formalized. There were rules for everything: how high a building could be, what colors could be used, where doors and windows should be placed. These weren't suggestions, they were law. At first, this standardization created visual harmony and preserved cultural identity. But standardization has a cost. It stops experimentation. It punishes innovation. Meanwhile, the rest of the world kept moving. Europe entered the Renaissance. New materials were tested. Iron and steel started replacing wood and stone. Buildings grew taller, more complex, more daring. China had the knowledge to compete, but knowledge alone doesn't create progress. You need permission to try new things. China's system did the opposite. Success meant mastering what came before, not imagining what could come next. Then came the wars. The Opium Wars, the Taiping Rebellion, the fall of the Qing dynasty, the Japanese invasion, the Civil War. By the mid-20th century, much of China lay in ruins. Cities needed rebuilding. Infrastructure needed replacing. But here's the thing about hitting bottom. It gives you permission to start over. Soviet-style concrete blocks dominated. Function over form. Speed over quality. These structures weren't meant to last centuries. They were meant to house people now, immediately. Yet even in this desperate construction, something was brewing. The same nation that once organized millions to build the Great Wall was relearning how to organize at scale. By the late 20th century, China stopped debating and started building. The pause was over. 1978 changed everything. That's the year Deng Xiaoping launched economic reforms that transformed China from an isolated, agrarian society into an economic powerhouse. But this story isn't about economics. It's about what happens when you suddenly need to house, transport, and provide infrastructure for the largest population migration in human history. People moved. Hundreds of millions of people, from rural villages to cities, from farms to factories. They came seeking opportunity, seeking work, seeking a future their villages couldn't provide. The cities weren't ready. Beijing, Shanghai, Guangzhou had infrastructure designed for populations a fraction of what arrived. Imagine your city's population doubling in a decade. Now imagine it tripling. Now imagine you're responsible for housing them all, feeding them all, moving them all from home to work and back again. This wasn't a construction challenge. This was a survival challenge. The same type of existential pressure that led ancient China to build the Great Wall. Just a different threat. Not invasion from outside, but collapse from within. Traditional construction methods couldn't keep up. There wasn't time. People were arriving now. They needed housing now. So China did what it had always done when faced with impossible problems. It thought at scale and organized accordingly. First came the special economic zones. Shenzhen became the testing ground, a fishing village of 30,000 people designated to become something more. In 4 decades, it grew to over 12 million. That's not a city growing, that's a city being invented. Prefabrication became standard. Why build each building from scratch when you can manufacture components in factories and assemble them on site? Entire apartment complexes could be erected in months instead of years. The quality wasn't always perfect, but they were fast, and fast was what mattered. The speed shocked outside observers. Western journalists would visit a construction site, return 6 months later, and find completed neighborhoods where dirt lots had been. But China was learning. Each project taught lessons applied to the next. Each failure led to improved standards. The vertical revolution had begun. If the Great Wall stretched horizontally across mountains for thousands of miles, modern China's answer was to build that same ambition vertically into the sky. The skyscraper boom wasn't about prestige. It was about mathematics. When millions of people need space, and you have limited land, you have exactly 2 options: expand outward or build upward. Expanding outward consumes farmland that feeds the population. building upward solves the space problem without creating a food problem. So, China built up. And it built fast. Shanghai's skyline tells the story perfectly. In 1990, the city had essentially no tall buildings. Today, Shanghai has more skyscrapers than any city in the Western Hemisphere. The Pudong district went from farmland to one of the world's most impressive skylines in roughly 25 years. But China didn't just copy Western skyscraper design. It reinvented the entire construction process. Traditional skyscraper construction is slow and sequential. China made it parallel. While foundation work continued on lower floors, upper floor modules were being manufactured off-site. Multiple teams worked simultaneously on different sections. What would take 5 years elsewhere took 18 months in China. The technique is called modular construction. Factories produced entire bathroom pods, complete with plumbing and fixtures. Hotel room modules arrived 90% finished. Structural columns and beams were fabricated to millimeter precision and assembled like massive Lego sets. The Shanghai Tower demonstrates this evolution. At 632 meters, it's China's tallest building. Construction took only 6 years, despite its complexity. The building has 9 vertical zones, the world's fastest elevators, and a double-skin facade that improves energy efficiency. It was built using techniques that didn't exist a generation earlier. Speed became a design philosophy itself. China has built more skyscrapers in the past 30 years than the rest of the world built in the previous century. Third-tier cities have skylines that would be impressive anywhere, but building up was just the beginning. The real revolution wasn't about how high China could build. It was about how smart those buildings could become. Somewhere in the transition from building fast to building smart, Chinese architecture stopped being about structures and started being about systems. This is the shift that changes everything. A skyscraper is impressive, but it's still fundamentally a building. A smart city is something else entirely. It's infrastructure that learns, it's architecture that responds. It's an urban environment that treats data like ancient builders treated stone. Think about what a traditional city does. It provides shelter, enables commerce, connects people. It's essentially passive. Roads go where they were built. Buildings stand where they were placed. The city doesn't adapt to how people actually use it. People adapt to the city. Smart cities flip that relationship. The city observes, analyzes, and adjusts based on real-time data from millions of sensors embedded everywhere. Traffic lights change timing based on actual traffic flow. Energy grids shift power to where it's needed. Public transit adjusts routes based on demand patterns. China didn't invent smart city technology, but it deployed it at a scale that makes Western implementations look like pilot programs. Hangzhou provides the clearest example. The city brain system processes data from cameras, GPS devices, smartphones, and sensors across the entire city. It monitors traffic in real time, predicting congestion before it happens. Ambulances get green lights along their entire route. The system identifies accidents and automatically dispatches emergency services. Travel times dropped 15%. No new construction required, just intelligence layered onto existing infrastructure. But traffic is just the beginning. Smart buildings adjust heating and cooling to match actual usage. Water systems detect leaks automatically. Waste management optimizes collection routes. Air quality sensors trigger alerts when pollution reaches dangerous levels. This is where the comparison to the Great Wall becomes fascinating. The Great Wall controlled physical movement across space. Smart cities do the same thing, but with information instead of people. Surveillance is part of this. Facial recognition cameras track individuals. Digital payments create records. The same sensors that optimize traffic also monitor citizens. For Chinese urban planners, this trade-off seems acceptable. They argue that when managing cities of 20 million people, you need data-driven systems to prevent chaos. The question isn't whether this approach is right or wrong. The question is whether it works. And by China's metrics, it does. Buildings don't just provide shelter. They shape how people live, work, interact, and think. And nowhere is this more visible than in modern China, where architectural transformation happened so rapidly that you can find people who remember both worlds. Talk to someone in their 60s living in Shanghai. They grew up in a traditional courtyard house, sharing space with extended family, cooking communally, living with minimal privacy, but maximum social connection. Today, they live 30 floors up in an apartment tower, surrounded by strangers, with their own kitchen and bathroom. More privacy than their grandparents could have imagined, but also more isolation. This isn't just a change in housing type, it's a change in social structure. Traditional Chinese architecture reinforced family bonds and community ties through shared spaces. Courtyards brought neighbors together. Narrow alleyways called hutongs created intimate neighborhoods where everyone knew everyone. Modern high-rise living does the opposite. You can live in a building with 500 families and never speak to any of them. The architecture enables individualism, even if that wasn't the conscious goal. Younger generations appreciate the privacy, the space, the modern conveniences. They don't miss communal living because they barely remember it. But elderly residents felt displaced, not just physically but culturally. The rhythms of traditional neighborhood life disappeared. Social networks evaporated when communities scattered across different developments. Then there's the smart city evolution. Convenience comes at the cost of anonymity. Facial recognition means your movements are tracked. Digital payments mean your purchases are recorded. For people who grew up expecting privacy, this feels invasive. For people who grew up with technology, it feels normal. Consider a typical day for a young professional in Shenzhen. Facial recognition payments, smart buildings that adjust automatically, deliveries sorted by AI. Every convenience came from surrendering data about yourself to systems that process it invisibly. Traditional Chinese architecture reflected Confucian values through physical structure. Modern smart architecture reflects different values: efficiency, optimization, data-driven decision-making. Both types shape behavior. Both enforce certain ways of living. The difference is that modern architecture's influence is invisible, running through fiber optic cables, which makes it more powerful, not less. The problem with discussing the future of Chinese architecture is that the future keeps arriving ahead of schedule. Forest City in Malaysia, designed and built by Chinese developers, isn't a vision of tomorrow. It's operational today. A city built from scratch with vertical forests, solar panels integrated into every building, a car-free ground level with all vehicles underground, and smart systems managing everything from waste to water. Back in China itself, experiments are happening that push even further. Xiong'an New Area, designated in 2017, is being built from the ground up as a model smart city. Not retrofitting existing infrastructure with sensors, but designing everything from scratch with intelligence built in. Every building, every road, every utility line, all connected, all communicating, all optimized. The vision includes buildings that generate more energy than they consume, transportation systems with no private cars, only shared autonomous vehicles, construction using entirely sustainable materials, waste systems that recycle nearly everything. Will it work? Parts of it already are. Other parts remain theoretical. But that's how China approaches innovation now. Build it, test it, learn from it, improve it. Then there's the vertical forest concept, spreading across Chinese cities. Chengdu's new development includes residential towers covered in plants. Not decorative greenery, but forests. Trees and shrubs on every balcony, creating oxygen, filtering air pollution, providing insulation. The engineering challenges are enormous. Plants need water, roots require space, different species need different light levels. But if it works, these buildings become air purifiers in cities desperate for cleaner air. Modular construction is evolving too. A company in Changsha built a 57-story tower in 19 days. Not 19 months, 19 days. The building was 90% prefabricated off-site, then assembled like stacking blocks. Building information modeling lets every pipe, wire, and structural element exist in the model before physical construction begins. Major projects now exist digitally before they exist physically. The building becomes less like a static object and more like a living system that can be monitored and treated. None of this is science fiction. It's all happening now. Let's end where we began, with a question. Not because we haven't learned anything, but because the most important questions don't have answers yet. How do you preserve culture while building the future? Walk through any major Chinese city and you'll see the tension. Ancient temples surrounded by glass towers. Traditional neighborhoods scheduled for demolition. Courtyard houses converted into trendy cafes for tourists. The old exists, but increasingly as performance, as museum exhibit, as something preserved rather than lived. Is that wrong? Maybe preservation is the best outcome. Maybe trying to maintain traditional architecture in a modern context is like trying to write with bamboo scrolls in the age of computers. Or maybe something irreplaceable is being lost. Not just buildings, but the knowledge embedded in them. Traditional Chinese architecture developed over thousands of years, solving problems specific to local climates and social structures. When you demolish a traditional building, you lose accumulated wisdom about how to live in that specific place. Then there's the human question. Smart cities optimize for efficiency, but humans aren't efficient. We take inefficient routes because we enjoy certain streets. We waste time in conversations with neighbors. We make choices based on emotion, not algorithmic optimization. What happens when architecture designed for efficiency collides with humans designed for inefficiency? There's also the question of control. The Great Wall controlled physical movement. Smart cities control information flow. Both represent power, but different kinds. You could see the wall, understand its purpose. You can't see the algorithms deciding what information gets prioritized, what behaviors get flagged. This opacity creates unease. And then there's the biggest question: what comes next? If Chinese architectural evolution teaches us anything, it's that nothing remains static. The Great Wall seemed permanent, yet it became obsolete. Traditional courtyard houses seemed timeless, yet they're disappearing. Today's smart cities seem cutting edge, yet they're already being superseded. So what replaces smart cities? Architecture integrated with artificial intelligence that predicts needs before they arise? Buildings that reconfigure themselves? Cities that grow organically based on population flows? Nobody knows. What we do know is this: China's architectural evolution represents one of history's most dramatic transformations. The story isn't finished. It might never be finished, because as long as problems exist, China will build solutions. The methods will keep changing. The mindset won't.